Hello everyone. Welcome to one more video on this problem is on integer programming problem. So we had one playlist on this channel about linear programming problem. This one is the next version or next difficult version, that is uh, integer programming problem. Okay, so the point is very simple, that in a linear program the variables are can be any fraction, whereas in an integer program the unknown variables are supposed to be integers. Okay, so in this example, for you see, uh, an industrial machinery manufacturing manufacturer produces shapers and drill presses. So in this case, the shapers and drill presses are integers. That means you can only manufacture, 10 shapers or 11 shapers or 13 shapers or whatever like that. You cannot go for answer which is 10.2 or 3.5, something like that. So the answer has to be a perfect integer. Yeah, so that is the thing, and it is very similar to formulating a linear programming problem, and then the solution we need to do it with the solver in the Excel sheet. Okay, so let me begin by explaining the problem. So start like this. So again, if you want to try yourself, please pause the video now and you try it yourself, and you compare your answer with my answer. So let's read the question. So an industrial machinery manufacturer produces shapers and drill presses. So, and if you want to confirm, you just go towards the end of this thing. The manufacturer wants to determine the number of shapers and drill presses. So this will give you more clarity. You know, you read the starting, you again jump to the end. Produce to maximize its profit. So profit needs to be maximized. Okay? So determine the number of clearly given. Okay? So let us define x1 is number of shapers, whatever it may be, and x2 is number of drill presses. Drill presses. So these are basically integers. Okay. You cannot have a 1.2 shapers or something like that. We solved another problem, chairs and tables. So that problem, how many chairs to be manufactured, how much wood is needed, labor hours is needed. There our answer was, like fractional. Okay. So, but that was under the topic of linear programming we did. Now, since this is a topic of integer programming, we are restricting this. Okay. So let us see. Next one. The manufacturer forecasts that demand for shapers for the next month will be at least 5. Okay, so demand for shapers, that is x1. X1 is at least 5. What does it mean? It's nothing but x1 will be greater than or equal to 5. Next, and the demand for drill press for the next month will be at most 7. Okay, so x2 at most 7. Okay, so simply x1, x2 less than or equal to 7. Okay, so we got these two constraints already. Shaper earns a profit of 40,000. So maximize the profit. Sorry. So 40,000. Okay, so 40,000 multiplied by x1 plus drill press earns 50,000. So 50,000 x2. This is the profit which needs to be maximized. And I already have two constraints here. So let me write down those constraints here. So constraints. So basically this is demand for x1 and demand for x2. So based on the forecasting, we know that. Okay. So x1 greater than or equal to 5 and x2 less than or equal to 7. Okay. Next, what are the other constraints? Okay. So again, let us see. Both the shaper and drill press use few common components like belts, electric motors, etc. etc. A shaper needs 15 units of such common components and drill press needs 18 units. The store has 200 units of the components in stock. Okay, so now let me write that. So this is components. So 15 units is needed by shaper. So 15 into x1 plus 18 units by drill plus 18 into x2. This should be less than or equal to 200 because 200 units of the components are in stock. Okay. The cost of other parts allocated from common budget. Okay, so common budget. So this is the budget constraint. Okay, which says 12,000 and drill plus needs 16,000. Okay, so 12,000 x1 plus 16,000 x2. The manufacturer has a budget of 150,000. Okay, so 150,000 is the budget. The manufacturer wants to determine the number of shapers. Okay, formulate the integer programming model, solve the model by using computer. Now, already our program has been formulated. Okay, so this is x1 comma x2 are integers. So whatever I kept inside this box, this is our integer programming problem. Okay, so now how to solve it? Okay, so let us solve it using the this thing. See, if I remove this last line, then it is a linear programming. If I add this, then it's an integer programming. That's it. So it should not be that difficult. So let us go to a empty Excel sheet. I'll solve using the Excel sheet. So a little bit I'm increasing the magnification. So here, let's start writing the details. Okay. So what are our variables? Okay. So our variables is x1 and x2. Let me write the names. So shapers and drill press. Okay. So and here the symbol or label. So x1 and x2. So next its values. Okay. So how many x1 should be manufactured? How many x2 should be manufactured? This is our question. So here I just give yellow color just to identify that these are the this objects, that is the things that needs to be uh, found out. Okay, so now let me write maximize the profit. So but first of all, what are the coefficients of the profit? Okay, so now if you see here you can see 40,000 and 50,000 are the coefficients. So let me write 40,000, 50,000. Now, if I multiply this with these two variables, okay, so since question mark is there, I'll put 0 so that it will be easy to multiply. So now I'm saying LHS, left hand side. So how it will be there? Sum product. So I have to sum product this array B4 and C4. So here I have to keep dollar sign before 4 so that when I drag the formula or when I copy the formula, it remains B4 C4. Next, the second array is this one, that is B6 and C6. Okay. So of course the sum product also 0. So now if I make one shaper, then here the profit is 40,000. If I make one more drill plus, the profit is 90,000. So like that I want to go for more profits. So let's give green color to the object which needs to be maximized. Now constraints. So what are the constraints? Okay, the first constraint what we wrote here, demand for x1, demand for x2, components and budget. Okay, so let's write components and budget first. Okay, so the order of the constraints doesn't matter. So as long as the constraints are defined correctly. The coefficients are 15 and 18. So this is 15, this is 18. And therefore simply I can say copy this. So here I don't need the color. So I'll just simply say no fill. Now this is the calculated value. Okay, so now what is the right hand side one? So it should be less than or equal to 200. Okay, so let's center justify all these columns. Next, components thing is over. What is the another constraint? budget constraint. So what is the budget constraint? So the coefficients are 12,000 and 16,000. So 12,000, 16,000. So this I'll copy and paste here, and then this should be again less than or equal to, and here this amount should be 15,150,000. Okay, so next, now our constraints: demand for x1, demand for x2. So what do we know about demand for x1? So here I have to give 1 and 0, and here 1 I have to give. So demand for x1 greater than or equal to 5. So greater than or equal to 5. So okay, and demand for x2 less than or equal to 7. Now this x1 and x2 have to be defined as integers. Okay, so we'll see how to do that. Now we have entered everything. So let's go for data, and okay, before that let me save this. So drill press. Okay, so I just give the name drill press. Now let us go to data, and let us go to solver. Now objective is to maximize, yes, and the cell that needs maximization is this one, which is E6. Now by changing cells, I change these two cells, and I will add the constraints. Okay, so this constraint less than or equal to this one, add this less than or equal to this, add, then the third constraint, this is greater than or equal to, so here we should carefully select that, add, and the last constraint, this one, add. So now I did not define the integer constraint. Okay, so let us simply solve this without that. So this is as if, like, I am solving a linear programming problem. So now I say solve. So solver found a solution. All constraints optimality conditions are satisfied. Say OK. So now the solver found a solution like this. Okay, so 5 and 6.944. See, obviously you cannot manufacture 6.944. So let us, but then at least just remember the profit maximized was file 54700. Okay, so now add the constraints also. Of course this is not needed directly, you can add, but just for curiosity I wanted to find. So go back to solver, then go for add constraints. So here directly select the yellow colored cells here. Okay, so these are your cell references, and here in middle you select int. See, there is a integer, then binary, and then diff. Okay, so just select the int integer. So diff means all different. Okay, so they should not have same value. Anyway, so int I'm selecting, and then say add. So now the integer constraint also added at the top of your constraint list. Now let us solve it and see what happens. So before that, make sure that here there will be ignore integer constraint. You should not check that. Okay, it should be unchecked. So just say OK. Now say solve. Solver found a solution and say OK. So now you see 6 and 6 is your optimal solution. So earlier the optimal solution for shaper was only 5, and this was 6.9 something. So now because this is 6.9 reduced to 6, this increased to 6. So this is the final solution, 6 and 6. And if you notice, this constraint is almost meeting, 198 less than 200 is almost meeting. And how about this constraint? Wait a minute. I think there is some problem here. This should be less than or equal to, right? So let me check what happened. Data solver. So E9. Oh, I'm sorry. That condition itself is not added. Okay, so just say add. Good that I verified the answer. So E9 less than or equal to this one. So always when you solve it, just check whether all the constraints are. You may make a mistake in this one. Okay, so E9, no, E8 is there, E9 is there. What is this? G9. Okay, I think this is wrongly added. This I will delete. Okay, E9 less than or equal to G9, E8 less than or equal to, okay. So this looks correct. Okay, so solve. Okay, again the integer conditions also there. I'm sorry. Now this is the perfect correct answer. X1 supposed to be 11 and X2 is 1. So this is the correct answer. Okay? Again, sorry for the confusion. We gave the answer wrong, the data wrong or selection of constraints wrong. So be careful with it. Now the answer is 11 and 1. Okay? So that's it. So we this is a video about integer programming. So we have the question here. After reading the question, we formulated the problem, and then finally solution from solver. The solution from solver we have x1 equal to x2 equal to, the solution is 11 and 1. So that's it. See you in the next video on integer programming. Maybe I come up with more problems like this. Thank you.